am Pallavi. I am from Patnapur. I am pursuing graduation. Now I am second year mpcs TTW RJC at Utnur. Seminar I have chosen a subject that is computer science. In that, stack using array and queue. Hi, today my topic is stack using array. So, how to stack using an array? Stack is a data structure which is following leaf, that is last in first out. Let us show some examples in our general theme. Those are, see this example using FIFO food storing system. Whenever we are going to the food storing system, we are taking which is the first one item, that item we will take in. Another example is, come to the next picture. Here clearly you understand what is last in first out. See, we have here stack. First of all, we are doing what? We are doing adding the element and deleting the element. See here, which is the first element we are adding in stack, that elements we are removing. See guys, here in stack 5 elements are already there. So I am adding last element, that is sixth one. Now I want to remove that element. So what I am doing here, I am doing here which is the top one element. That element I will remove here. That is last in first out. Okay. Come to the next point. The data element which is the storage last in the stack, that is element at the top will be accessed first. Next, in a stack, both deletion and insertion take place at the top of the stack. Let us show you one example. Stack using array. See guys, here we have stack and array. Array is known as collection of elements or data, anything. So here commonly we are using array to 0th index. So here in stack we are adding element upward direction. In array we are adding element towards, means left to right. In stack we are adding upward, means down to up direction. So array is start with 0 index. So in stack 6 elements are there. First element is 12 and next 8, next 21, next 33, next 18, next 40. Then 40 is the top of the element. As well as in array, I already told you array is started with 0 index. So 0th index I will adding 12th element. Next what? 8, next 21, 33, 18, 40, like that. Next is some example of stack. Some real life example of stack. A stack of trays, a stack of books, a stack of shirts, a stack of boxes, a stack of coins, like that. See guys, some example of stack. So I am here taking one empty stack. In stack, some operations are there. Those are, first one is a empty. Is empty is a function, means to check the stack empty or not. So here I am checking here one stack. Here this stack is empty. Come to the next operation, that is push. Push means insertion the element in the stack, means addition, add the element in the stack. Now I am taking here one example, that is, see here I show you. See here, push. Push means what? Insert the element or add the element. See here I am adding here 2, means pushing here 2. And next, come to the next part. I am here pushing the third element, means I am adding 3. And come to the third, I am there adding 4. And next 5, next 6, like that. Add the element is called push. Here We are adding down to up. We are adding upward direction. Next operation. Next operation is a pop operation. Pop means delete the element. Mean, see here, to delete the element from the stack. For example, see, there in push operation we are add the element. Now here pop operation we are delete the element. Here sixth elements are we are deleting, not adding. Here we are pop means deleting. Next fifth is deleting. Next fourth also we are deleting. Next third element also deleting. Last is a two element is a deleting. Remaining what? 1. We have to 1 also deleting. Then our stack is a empty. Okay. Next operation. Next operation is top. Top. Top means what? Which element is top of the stack? To display the element at top. See here example. See here we have one stack. Top one what? 1. Next 2. Next 7. Next 6. Like that. Here we have one element is the top of the element. Next operation is full. Is full. So we check the stack. Stack is full or not. Means stack is full or empty. So we are here one example. See here we have one stack. Stack is a full. So we can't add any more element now. If you want delete the element you can, but you can't add the element. If you add the element in full stack, the stack is said to be overloaded. If the stack is overloaded, then happening this like, see here. The main stack operations are pop, push, empty, full, top. Those are the stack operations. And another topic is queue. In general life, queue means lines. Example of passenger are entering bus and you want to buy any tickets, flight tickets or train ticket. You should maintaining line means queue. And in banking also. Queue is a linear data structure. It is a first in first out or last in last out. First in first out is FIFO and last in last out is LILO. In this queue has two parameters. First one is front and second one is rear. What is mean front and what is mean rear? Let I tell you what is mean front. Front is delete at the end part is called front and rear means insertion at the other end part is called rear. See that example. I have a queue. Queue has a two parameter. First one is front and second one is rear. In front they are deleting the element. In rear they are adding the element, inserting the element. See another queue. In 0 index we have 1 in that is a front and last index is 6th. There is no element, that is empty. Come to the 5th index, there is a 10th element, that is a rear. A queue is an abstract data type in which occur insertion at one end, that is rear, and deletion occur at other end, that is front. Abstract data types. In queue abstract data types, the basic operations performed on queue include adding and deleting an element, traversing the queue, checking whether the queue is full or empty, and finding who is at the front and who is at the rear end. First one is create an empty queue, and second one is add the element into rear end, and third one is delete, remove the element at front end, and fourth one is get front element should be found, and fifth is empty, return true if the queue is empty. First of all, create one empty queue, and next to add the element into rear part. Rear part means last part, and delete the element at the first part in front and get front, and last one is empty. Queue is empty or not. Realization of queue using arrays. Queue are implemented in two ways. First is array and next linked list. Queues using array called static queue. The implementation on the queue using array. Enqueue. Enqueue means for inserting. Sorry, there is one mistake. There is not inserting. There is inserting an element in the queue. For inserting an element in the queue. Next one is dequeue. Dequeue means user for deleting an element in the queue. And create. It is used for creating an empty. Enqueue means inserting the element in queue, and dequeue means deleting the element in queue. Array implementation of queue. See there, guys, where they inserting a element in queue. First initial queue, first front is 0 and rear is 3. 0 and 3, those are indexed, not elements. Elements are 17, 23, 97, 44. 17 is in 0th index and 44 is in 3rd index. So here after insertion we are adding 333. After insertion, look like that. After insertion, first 70, next 23, next 97, next 44, next 333. After deletion, we are deleting in first part, not a rear. We are deleting here first 0th index. We have 17th element. We are deleting 17th element. See that we are already deleted 17. Look like that. Then 23 and 97, 44 and 333. See here enqueue and dequeue. I already told, but again I am repeating here. Enqueue means adding the element and dequeue means deleting the element in the queue. See here enqueue and adding, dequeue is deleting. Look like this.